In the United States, between 1992 and 2010, almost 5,000 people were killed on the job by electricity. Many of these deaths and thousands of other serious injuries could have been avoided. These descriptions from the OSHA website are cold and impersonal. They don't tell the story of the pain the victims and their families went through. Don't become a statistic. Learn how to work safely around electricity.
Hey guys, let's do our pre-job survey.
Before you perform any work, you need to do a complete pre-job survey. It's a simple way to help make sure that you identify, remember, and avoid hazards. If you are unsure of what is involved in a pre-job survey, talk to your supervisor. Training material is available. Hazards in the form of primary wires, secondary wires, house services, transformers, and power company guys always exist on joint use poles. As long as they are constructed properly and do not enter our workspace, then they are controlled. We can work safely around them as long as we remain aware of where they are in relation to where we are working. As you perform your pre-job survey, there are a number of potential hazards to look out for. Review your work print for any useful information about the power in the area. Look for wires down, posted high voltage lines, low clearances, sparks, arcing, glowing wires, smoke, charring, or any evidence of contact between Verizon plant, power lines, and trees. You might not think that tree limbs are a good conductor of electricity, but make no mistake, they are. They contain moisture and are a direct path to ground. Be aware of contact between tree limbs, our plant, and electrical conductors. Listen for buzzing, humming, or hissing sounds. Be alert to the smell of hot or burning material, insulation, smoke, or ozone caused by arcing. On power company equipment, look for missing or damaged insulators, slack power wires that don't seem to be attached correctly, power wires in contact with our plant, and power guides that run through our workspace and are uninsulated or inadequately insulated. Don't touch anything that might be an electrical hazard. Your voltage detector is your best friend and must be used on every job on anything that could be energized.
And don't forget that tree limbs and guys can move after you've tested them, so retest if necessary.
On joint use poles, you need to test all objects in the workspace: strand, hardware, terminals, poles, and bond anything that could become energized. Here are some other clear examples of hazards.
Here, someone has placed a protector to splice out a drop wire and has put it too close to the streetlight bracket. Don't work on something like this. Refer it to your supervisor. On poles with an MGN, multi-grounded neutral wire, if it's missing or broken like it is here, inspect one transformer on either side of the pole you'll be working on. If you don't see an MGN, notify your supervisor. Even if there is an MGN in good condition, check it with your voltage detector before proceeding. In this shot, electrical wires are coming down from the secondary, touching our plant and hanging in a coil from our terminal box. If that wasn't bad enough, there is a bare conductor. There is also a power guy coming through our space, touching one of the guides without an insulator on it. You should always call in a situation like this. In this shot, there is inadequate mid-span clearance between our cable and power. Here's an example of electrical service running too close to our cable. Here's another example of electrical guys coming through our space. They have no insulating rods up top. Here we have a down guy, again with no insulating rod, entering our space, right next to a telco service box. And finally, in this shot, someone has tied telco cable directly to power, no doubt to increase road clearance. Always report a hazard like this to your supervisor. Don't wait for the next person who sees it to report it.
Between 1992 and 2010, of the nearly 5,000 people killed by electricity in the United States, 44% died by coming in contact with overhead power lines. You need to know what the proper clearance is, both on poles and at midspan. If the proper clearance does not exist, do not proceed and immediately notify your supervisor or other management. Remember, a clearance is the distance that other utilities, such as power or CATV equipment, must maintain in relation to our telecommunications equipment at poles and at midspan. The distances increase as the voltage increases. This chart describes necessary clearances on joint use poles. On power circuits of between 0 and 8700 volts, the minimum clearance is 40 inches. For transformer cases or capacitors that are not grounded, the minimum clearance is 40 inches. For transformer cases or capacitors that are grounded, the minimum clearance is 30 inches. For transformer cases or capacitors over 8700 volts that are not grounded, the clearances are 40 inches plus 0.4 inches for every 1000 volts over 8700. For power circuits of 8700 volts to 50,000 volts, you can determine the safe clearance using the same formula. Street lights and traffic signal brackets that are not grounded should be 20 inches away from our equipment. Street light and traffic signal brackets that are grounded need to be 4 inches away from our equipment. The drip loop of a street light bracket needs to be 12 inches away. And finally, licensee standoff assemblies need to have a 40-inch clearance. If you cannot determine whether a transformer, street light, or traffic signal bracket is grounded, observe the maximum clearance. If these clearances are not present, do not continue and notify your supervisor immediately. Here is a chart that describes the clearances that need to be present when you are working on Verizon cables at midspan. For open power conductor cables, spacer cables, triplex and quadruplex power conductors, from 0 to 8700 volts, a distance of 30 inches needs to be maintained at midspan.
For other power conductor cables with a grounded sheath, less than 50,000 volts, a distance of 12 inches is needed at midspan.
For effectively grounded neutral wires, a distance of 12 inches needs to be maintained at midspan as well. Once again, if the clearances described are not maintained, do not proceed and notify your supervisor immediately. Besides clearances, the other critical component to staying safe when working near power is approach distances. An approach distance refers to the minimum safe distance you or any object you are in contact with can get to the energized conductor. Secondary conductors are typically used to supply voltage to a residence and are under 300 volts phase to phase. For this category, simply avoid contact to stay safe.
For conductors between 300 volts and 750 volts, maintain a 12-inch approach distance. For conductors of between 750 volts and 2000 volts, maintain an 18-inch approach distance. For 2000 volts to 15,000 volts, keep a 24-inch approach distance. For 15,000 volts to 37,000 volts, stay 36 inches away. For 37,000 volts to 87,500 volts, stay 42 inches away. For 87,500 volts to 121,000 volts, stay 48 inches away. And finally, for 121,000 volts to 140,000 volts, maintain 54 inches between you and the energized conductor. If you're not sure what the required clearance or approach distance is, check the Trifold electrical safety handout available in the Verizon ordering catalog. You should always have a copy in your vehicle. If you don't, get one from your supervisor.
The bottom line in all this, what you should remember, is that after 350 volts, it's called primary voltage. And if you're not sure what you're dealing with, if it doesn't say it clearly on your work print, consider whatever you are dealing with to be the maximum voltage and maintain the maximum approach distance. And don't forget to include any tool or piece of equipment you are in contact with in your calculation. If these approach distances cannot be maintained during your work operation, do not proceed and notify your supervisor immediately. When there are overhead power lines present, never violate the minimum approach distance and place your bucket above our plant. Where obstructions exist, such as trees, never attempt to place a service wire or cable by lifting it over the obstruction. Use layup sticks to fish a non-metallic line past the obstruction and continue work from the other side. Never throw a drag line through the obstruction when there is overhead power present. I&M FiOS techs are exposed to electrical hazards outside and inside customer premises. Although voltages might not be as high inside, the risks for injury or even death still exist. When working on the outside of a customer premise in the proximity of the electrical meter pan, always be sure to test using your voltage detector to determine if a hazard exists from inadequate grounding of the electrical equipment. Before drilling an entrance hole for a service wire, be aware that electrical wires may be running inside the wall. Always check inside to determine the location of electrical boxes, lines, outlets, etc. Take specific measurements to determine where your entrance hole should be located. Drill a pilot hole from the inside to the outside before drilling your service wire hole. Remember, measure twice, drill once.
Look at this photo from an actual incident where an associate drilled without measuring. His drill bit pierced the electrical wire and started a fire inside the wall.
When drilling, if your drill bit encounters an unusual amount of resistance, do not force it. Pull the drill bit out and look to see if it shows evidence of contact with electrical wire or equipment. If it does, do not proceed and notify your supervisor immediately.
From time to time, foreign voltages have been encountered on set-top boxes during installs. This can be caused by faulty wiring in the customer's wall outlet.
For this reason, it is necessary to test the wall outlet for continuity before plugging in the set-top box. As always, if you're using a C9970/188A detector, do a self-test before use. And if you have an FVD, press the on button and allow the detector to cycle through its test before using it. Plug your TII 442 grounding module into the outlet nearest the set-top box. Touch the ground leg on the device with your voltage detector to determine if it is energized. If it is, do not proceed. Look for another outlet. If one is not available, notify your supervisor immediately. Remember, coaxial cables, component, or HDMI video cables and TV sets can also be energized. For more information, refer to the Verizon Safety Lesson Plan on the use of a foreign voltage detector in an inside environment, VZ Learn number YYJ S0319. Survey your work site. Learn to identify hazards, recognize safe clearances, and maintain approach distances. Use your PPE and voltage detector. Take the extra minute. It might save your life. Because when you work safe, you don't do it to maintain a company safety statistic. You aren't a statistic, you're a person. Work safe for yourself and your family, because that's what's most important in your life.